As developers, we build critical infrastructure. It's time to build it in a language that's designed to build critical infrastructure. How often have you seen this kind of code? What problems might there be here? The biggest problem here is that this line will page you at 4 a.m. Unsafe assumptions crash our programs at runtime and wake us at 4 a.m. This is exactly as unsafe as the Python solution, but the 3 places it can crash are now explicitly stated. If you want it to never crash, you find alternatives for those unwraps. Here's a verbose version of what that might look like. Rust will not let you write unsafe code from the start. You must handle all errors. An idiomatic Rust solution looks like this. Don't worry too much about the specifics here. We'll talk about basic Rust syntax soon. I just wanted to give you a taste. Broken software hurts people and slows down human progress. We now have a much better solution to these problems. Rust is a really pleasant language to write code in, but that's not what we're here to talk about. We're here to talk about making perfect software. I've been searching for many years for systems, frameworks, and methods to make my code more reliable or guaranteed. We as developers accept that our lives are governed by errors, often bullshit errors like these. I'm here to tell you that it doesn't have to be that way. You may have heard that Rust provides memory safety without a garbage collector. I don't care about memory safety. I've never had to. Java, Python, Ruby, Node, Go, they all ensure memory safety by running a second program alongside your program, checking memory is freed when it's no longer used. This is called, as you may know, the garbage collector. The Rust team identified the need for memory safety without a garbage collector as a key problem to be fixed. So they implemented a genius simple method to keep track of memory called the borrow checker. But here's the thing. In fixing memory safety, the Rust team accidentally fixed everything that I do care about. In making a compiler that understands your code in a very deep way and a rich type system that supports that compiler, they gave us, the developers, all of that control, all of that potential to build the perfect language and ecosystem. The Rust community, over 16 years, has delivered. Rust has a familiar C-like syntax that JavaScript, Go, and Java developers will be familiar with. Even delicate Python developers, such as myself, won't be too confused. Here are functional style iterators, but this is just one of the many zero-cost abstractions that translate down to simple loops. No matter how clever your language is, the processor running your code only understands bits and a few operators. Rust gets your high-level code right down to that bare metal without sacrificing high-level developer ergonomics. Semicolons in Rust finally have proper meaning. Line-oriented statements, by the way, come from punched cards. Punched cards are statements. We can do better than this. In Rust, you can think in iterators, as data moving through mutation. You can use all iterator operations on options. There are no nulls in the whole language. In this example, a human has to be alive or dead, and has to live on a planet. No nulls, no anonymous objects. In Rust, you tell the compiler how the world works, and it will hold you and everyone who contributes to your code accountable to the contract you have written. This may be a new way of programming for you, but it's such a good pattern that it is now how I try to write my Python. Rust has a best-in-class package manager, solving all the dependency nightmares we face day to day. This is what you get when you have a community focused on correctness. In JavaScript, if you remember, we had to wait years for async and await to be standardized, and we still can't get it in all browsers. In Rust, it was a library. The language is extended with macros, code that executes at compile time, which are installed as simple libraries, same as everything else. Macros convert new syntax back to type-safe Rust, which is then fed into the compiler. You don't have to throw out the safety features of Rust to use new features today. If you used Babel, Webpack, or the million other JavaScript precompilers, you've used a bad, error-prone, ill-defined macro system. Here is how you write a simple GET request in Rocket, which is a Rust web framework. You can probably read this without my help. It's a pattern we've all seen before. The first line isn't a comment, though. It's a macro, which rewrites the enclosed function before the source code gets passed to the compiler. It's a simple Hello World HTTP endpoint with built-in compile-level validation of guaranteed valid strings, and a rudimentary understanding that people shouldn't be negative years old or over 255. I'll admit, that's optimistic validation. But we can do better. We have the technology. Don't be scared. I promise we can get through this. Let's reason about this short piece of code. It's still using the Rocket web framework, by the way. Think of it as a Sinatra or Flask equivalent. If our program compiles, we know many things are guaranteed. ID will be a valid UUID from a valid HTTP path. The return JSON will always be in the schema we designed, named form response, with defined values acting as the contract we can never break with our API clients. SQLX actually runs that query on my local dev database with a valid test input generated on the type, in a rolled-back transaction at compile time. If it is invalid, my code doesn't compile. Yes, this is magic. Rust magic. So far, so great. But there's more. No memory leaks, no SQL injection, all guaranteed at compile time, and you get all of this with no heavyweight, slow abstractions. This all compiles down to for loops and if statements, close to the C speed, running on bare metal. But we can do even better. By adding the forbid unsafe code directive, we forbid the unsafe block, and therefore any linking to operating system libraries, i.e. external C code, guaranteeing our app and all its dependencies are pure Rust, and therefore do not break any of our guarantees. But what about native libraries that you need to link to, such as libpq for Postgres, Pandas, NumPy, or OpenSSL? The Rust community has rewritten all of these in pure Rust. Not even OpenSSL has escaped oxidization. The last 40 years were written in C. The next 40 will be written in Rust. In writing this, I wanted to invite you to get in on the ground floor with Rust, as it's going to be an industry-changing ride. However, as I wrote this, I realized you actually have some walking to do. The Rust lift is currently on the 16th floor. There are more Rust projects on GitHub than Scala, Kotlin, Swift, CoffeeScript, and Perl. It is time to take Rust seriously. First in your personal projects and learning, and soon at your work. Because finally, our code can be perfect.